Now let's see how you can calculate sum of first n terms of an AP. Let's say an AP is in the form A1, A2, A3, A4. The first term is A and its nth term is, or the number of term is n, and the common difference is d. So if you want to calculate the sum of n terms of an AP, let's say first n terms, a nth, it can be a finite or infinite AP. If it's a finite AP, then you will know that the number of terms is definite there, and if it's an infinite, then you can have as many terms as you want, but you can calculate sum of first n terms of this AP. So the sum of these terms is going to be the first term A1 plus A2 plus A3 plus A4, and let's say up to n plus an. Now you know that A1 is going to be A plus A2 is going to be A plus D. You know it from the general formula for AP. The third term is going to be A plus 2D, plus the fourth term is going to be A plus 3D, plus and so on until you get the nth term. It is going to be A plus n minus 1 times d. That's what we know, the nth term, an. Now I just want to flip this equation. I want to start it from the last to the first. That means I want to put the last term first. A plus n minus 1 times d plus A plus n minus 2 times d. I'm moving from here, okay, from the last term, plus A plus n minus 3 times d, plus and so on until I get to the first term, that is A. I just flipped this order. That's what I did. And now I want to add these terms, and I will add the first term to the last term. I will add this term to this term, the second term to the second last term, and the third term to the third last term, and so on. I'll add each term of the first of this AP to the each term of the other one, and each term of the equation 1 to the equation 2. So that's what I get. But you will see that if you add the first and last term of this, the second last term of this third, and you will see that you're going to get the same result every time. For example, let's say these terms, first these two, A plus the first and the last term, A minus 1 times d. You're going to get A plus n times d minus d, 2A plus n minus 1 times d. Sorry. And now if you add this second term and the second last term, that's highlighted in yellow, these are A plus d plus A plus n minus 2 times d, that means nd minus 2d. So A plus A is 2 times A plus minus d minus 2d plus d is going to be minus d plus nd. So it's going to be 2A plus n minus 1 times d. And it's true for each term. for the third term plus the third last term. If you add those, you will get the same result, 2a plus n minus 1 times t. Now you can keep doing this, but how many times will you do this? There are n terms. It's an, the term is an. That means you will get this n times. So it is going to be 2a plus n minus 1 times t times n. And this s and s, you added both the equation, is going to be 2s. So 2s is going to be 2a plus n minus 1 times t times n. That means 2s is going to be n times 2a plus n minus 1 times t, or s, that is the sum of first n terms, is going to be n over 2 times 2a plus n minus 1 times t. So that's how you calculate the sum of the first n terms of an AP. The sum is n over 2 times 2a plus n minus 1 times t. Now there are other forms of this formula. You can derive those forms from this formula. So let's see what are the other forms. Other forms of this formula. So if sum is n over 2, 2a plus n minus 1 times t, you can also write it as n over 2, a plus twice a is going to be a plus plus n minus 1 times t. And this one here, a plus n minus 1 times t, is going to be an, the nth term. The formula for a plus n minus 1 times t is an. So you can also write it as blue. S equals n over 2 a plus an. And if the AP is finite, let's say the nth term is where the AP terminates, then this term is going to be the last term, an going to be the L, the nth term is going to be the last term. So you can write it as S equals n over 2 a plus L. Here you are calculating the sum of the whole AP, not some n terms. An AP can be finite, but still you can take n terms and then find the sum of them. But here when I say an, that means that term is going to be the last term, L. Now how do you find out? Well, let's say these numbers are positive integers. First let's say positive integers 1, 2, 3, 4 and 5. So how do you find sum of first n positive integers? S and positive integers are always going to make an AP 1, 2, 3, 4, 5, 6. The common difference is always the same, so they're in AP. That means, let's say if you want to find out the sum of first n positive integers, then it's going to be n over 2 a, the first term. Positive integers are going to start from 1, not from 0. 0 is a neutral integer, not a positive, so it's going to start from 1 plus a plus an. The last term is going to be an or L. So the last term is going to be the number, because natural positive integers are going to be numbers, so it is going to be the last number. An is going to be n. For example, the last term is 5, this is also the number of term 1 2 3 4 5. So the term itself is the number, so it's going to be 1 plus n, so n over 2, n times n plus 1 over 2. So the sum of first n positive integers is going to be n times n plus 1 over 2. What if these integers are negative? For example, it's -1, -2, -3, -4, and so on. Well, one way of doing is you take the -1 out, you multiply the whole series by 1, 2, 3, 4, 5, and so on. So you will see -1 times, now if you take the sum of it, it is going to be s is going to be n times n plus 1 over 2. So it's going to be -n times 1 over 2. You just multiply by negative. And there is another way, which is it's going to be n over 2. S is going to be n over 2. The first term is -1, a plus an. An is going to be, the value of an is going to be a last term. The last term is going to be, negative of the number of term. That is, if there are 4 terms, 1 2, for example here, highlighted yellow here, if the number of terms are 4, but the value of last term is negative of the number of terms, that is, the value is -n. N is not negative, but its value is -n. So it is going to be, S is going to be -n times 1 plus 2. Same thing that we derived above here. So that's the sum of first n negative integers.